Hi, it's Mrs. Ratcliffe here, and I'm talking to you now about some more interesting information about exponents. So just a reminder, exponents are also called indexes or indices, and exponent just is another operation that describes a number being multiplied by itself. So one thing to know is numbers that are to the power of 2 are often called squares. Or if you raise a number to the power of 2, you're squaring it. Okay, and we looked at this in class, but the reason why is because if you look at this is a visual depiction of 2 to the power of 2, and there we have it 2 across and 2 down. That's how you would find the area of a square. Okay, so the same here. This is 4 to the power of 2, and here it is visually depicted. 4 across and 4 down makes a perfect square. So whenever you have a number squared, that resulting number is called a perfect square. For example, this one is 4 and that one's 16. 16 and 4 are perfect squares because if you did that operation in reverse, you would have an even number. In other words, a whole number. Okay, not an even as an even and odd, a whole number, no leftovers. Okay, to find the square of something, as we worked out, you're multiplying the number by itself. So square roots. Now, I just want to explain what a square root is for you so that you get it. Basically, an exponent is an operation, and finding the square root is the reverse of that operation. The same way that multiplying is one direction, and then if you do the opposite thing, it's dividing, or it's what adding and subtracting are to one another. Square root, you're finding the square root. It's the opposite direction to squaring something. So, for example, if you have a 5 and you square it, 5 to the power of 2, or 5 squared, equals 5 times 5, which is obviously 25. Okay? So to take the square root of 25, you will have 5. Okay? The symbol for a square root is that it looks like a check mark that's sort of it's like a check mark that's grown too large. So that's a square root. So if you see that sign, it means it wants you to take the square root of that. So it's easy when it's numbers that we are familiar with that are perfect squares. For example, the square root of 16, we know that's 4. But you can have square roots of things that don't result in a whole number, and those are called irrational numbers because they make no sense. They can repeat and go on forever. Okay, enough said about that. We don't need to go into that too much in year 7, but it's good for you to be familiar with it. It's good for you to recognize the sign that shows you what a square root is, and it's good for you to understand that it's the opposite of squaring something. Okay. Hope I haven't fried your brain there. Now, if you take a number to the power of 3, you can call it cubing something. Okay? A number to the power of 3 can be called cubing. So if I have 7 to the power of 3, I can say 7 cubed. Okay? That's got to do with the same phenomenon that I showed you with the square, only in 3 dimensions. And it means that if I had a 3D, like if I had a Rubik's Cube or something here, I could find one dimension, like the length of it, and cube it, and I would have the area of that cube. Okay, we'll look at that a little bit more when we're looking at measurement, but it's kind of good to know and relate that back to it later. So for example, here we have 5 cubed. That's the same as saying 5 times 5 times 5, which equals 125. Okay, and just for your information, you can have a cube root too. So you could say, what's the cube root of 125? And you would know it would be 5. Okay. And the last little bit of information for you, just an interesting fact or two more about exponents, is that there's a thing called scientific notation. Just important, it's worth you being familiar with it. And the idea with scientific notation is just that, particularly in science, sometimes scientists are working with numbers that are extremely large, such as the distance between the Earth and the nearest star, or stuff that's extremely small, such as the distance between subatomic particles in an atom. And it's so difficult to try and print a number that large or that small on page, so they will use a shortcut or an abbreviation that they call scientific notation. And scientific notation looks like this. You might say 2 times 10, this is example, 2 times 10 to the power of 12. So that's like saying 2 times, and 10 to the power of 12 looks like this. It's got 12 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, you can make a little more sense of that if you put some commas in there, but you can see that it's a big number. So really, then you would multiply it by 2. So you would have a 2 in front of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that is why you can see why they would write it in scientific notation. Okay, it's not going to be testing you on this, but it's just worth you being familiar with that style of writing exponents so that you're aware of it. Okay, hopefully this more on exponents video hasn't fried your brain, but just made you more aware of and familiar with some different uses of and different ways that people use and show exponents. Okay, good luck.